All right, it's December 23rd. I'm Ken Eklund. It's December 23rd, 2021. And I want to make another short video. This is about gravity. And I like this guy here. He's explaining Einstein. I think Einstein is wrong, but he's doing a good job explaining Einstein. And it's okay if I show, this little part of his video. As long as I'm not saying it's mine. It's not mine. I'm just critiquing it, which is okay to do. It's okay to critique it. Um, Let me just run it for a second.
We call this their four velocity. To get at this, let's move away from our teapot for a second and talk about boats. Imagine two boats on an actual stream. One near the edge moves slow and one near the center moves fast. The slow boater reaches out an oar which the fast boater grabs. What happens? Instinct tells us that the fast boat is pulled towards the shore. We can think of the two objects as becoming one object, and the difference in velocities across its length causes a torque that rotates the overall velocity vector towards the shore. It's the same with the four velocity of an object in a gravitational field. The gradient of velocities causes the overall four velocity of the object to be rotated. All individual four velocities start out being pointing purely in time, but the sum is rotated partially into space
Okay, let me go
towards the
back
shore.
because I don't think this is right, and it kind of contradicts another example they give. Um, Now, I think I've spent a lot of time around water, and you have to be very careful swimming and boating because currents will just take you away. And currents aren't always pushing you to the shore. So you got to be really responsible and careful. If you get in this water, you could be washed out to sea or wherever this is going. Same way with a boat. You got to tie a boat, right? Have you ever heard of somebody not tying a boat? Uh, so watch this.
Instinct tells us that the fast boat is pulled towards the shore. We can think of the two objects as becoming one object.
Okay, this red boat, canoe or boat. If this would only happen if he threw an anchor out and it dropped over here, and he was anchored, and then he would make a circle, and it wouldn't push him into shore, but it would push him right here. Or if there were two people in this boat, one person in this boat, and this one's heavier, this would be like an anchor, and it would start pulling that one over there. But I actually made uh, a little canoe, a little pontoon boat, is what he's saying. Uh, Once they're connected, it's a pontoon boat. And he's saying, well, I just experimented with this. I went outside. It's raining right now. So I went out and I put this in the street because there's water running down the curb. And it's slower next to the curb, and then it's running fast a few inches away, like in the middle of the water, and then it gets slow again as it gets farther out into the street. So there are the currents there, but what happened was it didn't get pushed into the curb. What happened was the faster currents would push this side, but then it would start spinning. It would keep going in a straight line, but it would just spin. After a while, it might stop spinning, but then something else. It'd be like a slight change in something, and it might spin the other way. Then it would spin, but it kept moving, and it would go all the way down the street if I didn't catch it. Uh, I even tried a little pocket. There was a where the curb, where the driveway is. There's like a little place like this where the water's very slow, and once it would slow down there, but then eventually the faster current would take it away. So, uh, what this guy is saying is every time, I don't know if you heard that part, I'll let it run next time, but he says every time uh, the this boat would be pushed into the shore, or if this is Earth, it would be, uh, time and space would make it crash into Earth. But I'm not seeing that. And then the thing is, it contradicts this other thing they say, where if you're standing here, your feet are in a slower time than your head, and uh, that's why we have gravity now, and that's why you can stand up on Earth. And um, so they're saying, and they also say that's why the GPS clock in uh, up in space runs faster. It's because time is faster as you get away from Earth. So your feet are in a slower time. Your head's in a faster time. Uh, but here, so your feet are being pulled down first, and then your head. But here it's the opposite. It's the thing farthest away from Earth that's being pulled in. And let me fast forward it, because, or just let it
And the
run,
difference in velocities across its length
because
causes a torque
he shows
that rotates the overall velocity
the
vector
teapot
towards the shore.
doing the same thing.
It's the same with the fall velocity of an object in a gravitational field. The gradient of velocities causes the overall fall velocity of the object to be rotated. All individual fall velocities start out being pointing purely in time, but the sum is rotated partially into space. And it's always rotated in the direction of the decreasing flow, which in a gravitational field is downwards. So, this is the motion of an object in a gravitational field. It gradually picks up velocity in the down direction. It accelerates, and it pays for that acceleration by losing velocity, decelerating in the time direction. There's a certain way of interpreting the math of relativity that says that everything travels at the speed of light. Light travels at the speed of light through space.
Okay, so he said every time this is going to happen, an object is going to drop towards Earth because of these different currents. And it's but if this contradicts the other thought experiment, because in the other thought experiment, the closest thing to Earth is in a slower time, like here, and that's being pulled in, and this side wouldn't be pulled as much. So the handle would be pulled down towards Earth, and not the spout. But in this thought experiment, it's like the spout is turning around. Weird. And but a meeting. I'm not meeting them. It'd be interesting to meet these people, but I'm texting with, or writing with some of these physicists. They're very interesting. This one guy. It's very complicated, though. It's time is dependent on the physical change of objects, but the physical change of objects is dependent on their physical relations and the fields they interact with or emit. I mean, that's a lot. That's a lot right there. And it sounds like, it's Einstein stuff, and he wants to try to he wants to believe in it, but he's having trouble just really believing it and really understanding it. And I don't blame him. Uh, I don't want to say these physicists have, drank the Kool-Aid, but a lot of people are not believing this Einstein stuff now. Well, this is what I wrote him. I wrote, "Hey, thanks for replying. You have very interesting ideas. I just now watched a shoemaker video." He said, "Watch a shoemaker video." It was a thought experiment. To me, most thought experiments want us to assume things can happen, which I believe can't. I can't imagine a place without time. Earth is orbiting the sun. The sun is moving around the Milky Way, in the Milky Way, etc. If you want to measure the movement between objects to invent a sense of time, that's great. But light bouncing all over the place is a separate happening. Light is light. Objects are objects. A clock in space might tick faster, not because of relativity, but because there would be fewer forces affecting the mechanisms in the clock. Clock bias. Just because a clock ticks faster doesn't mean a person would age faster or some other outrageous idea. That's what I wrote to him. And he'll respond. It's all very interesting. It's like this interesting society of people into physics. And then look at this guy. He came up with this really cool thing. Check this out.
Cool again now, unless you're using it for a physics experiment, in which case it's extra cool. Just take your ball, and what do you think is going to happen if I put it right here on the record player? I know what my intuition is. I expect it to fly off. The ball doesn't go flying out. Instead, it begins to move in a circle. It even starts to move in toward the center, almost like it's on some sort of circular treadmill. Maybe if I could find a way to play with a bunch of treadmills at a gym, it could help me understand.
Well, you see, that's not this is it's not
Find a
some
way to play with a bunch of
metaphysical
sort of circular
type of
to move in
concept
toward the center.
that's really hard to understand. This
Almost like
is this is just a physical thing happening. It's it's friction. It's inertia. It's like things we can understand and see, and it actually works here. And this I got to study more. This is interesting.
to move in a circle.
Look at that.
It even starts to move in toward the center, almost
Yeah,
like
it's
it's
pretty
on some
cool.
sort of.
All right, so let's see. What else do I have? Uh, I guess that's it. All right. Thanks.